All right, we have lesson 4. This is going to be part 3. So in part 1, we talked about the unit circle and simplifying trig expressions. In lesson 4, part 2, we use that same unit circle and we graphed the cosine function. In lesson 4, part 3, this video, we are going to take that same unit circle. By the way, the unit circle doesn't change, okay? It's the unit circle. So that doesn't change no matter what math class you're in. We're going to use that same unit circle, and we are going to graph, in this case, the sine function, okay? As a gentle reminder, I'm going to let you know that the coordinate for the ordered pair that represents sine is the y value, okay? Couple things that may help you remember. If you can remember that your ordered pair normally is xy, a few teachers may have told you, myself included, the way you remember that is xy is alphabetical. So as you do your alphabet, it's x then y. If you remember your alphabet, you should also know that cosine comes before sine alphabetically. So you can use that same idea to help you remember xy is cosine sine. All right, that may or may not help. It's really up to you. So I'm going to go ahead and grab a sine value when sine of theta, for sine of theta is theta equal to 0. All right, so what is the sine of 0? So I'm going to roll on up here to my unit circle. I'm just going to be doing this back and forth to fill out this table. Okay, so 0 radians, 0 degrees, same thing. Ordered pair is 1, 0. Sine is the y value. So the sine of 0 is 0. I need to find pi over 2. Okay, so back and forth. So radian value pi over 2 is right here, and sine is the y value of 1. So scroll down. Okay, pi over 2, sine is 1. I need to find the sine of pi. Okay, back to my unit circle. So follow my radian measures around. Here is pi. Ordered pair is negative 1, 0. The sine value is the y, so that is going to be 0. Okay, so the sine of pi is 0. 3 pi over 2 is my next radian. It's down at the bottom of my unit circle here, so right here. 3 pi over 2, the ordered pair is 0, negative 1. The negative 1 is the sine value. All right, one more time back up to the unit circle, but this time I need 2 pi. Okay, all right. So 2 pi, remember, is the back to the start of the unit circle. So it's that one full revolution or one full rotation. And again, we're at the point 1, 0. 0 is going to be our sine value. Okay, so that was the last time making that back and forth jump there. So the sine of 2 pi is going to be 0. All right, so now I'm going to take these 5 values and I am going to plot them on my curve. Same thing as the cosine, the x-axis is notated in radians. Okay, it's marked off in radians, so I'm just going to use these radian values right here. So let's see, 0 radians, 0 on the y, so 0, 0 is the origin. Okay, pi over 2, 1, so pi over 2 is this next unit over, pop up to 1. Then I've got pi 0, so I'm going to go one more unit over, keep it on the midline. 3 pi over 2 is right here, but that's negative 1. And then 2 pi is to the middle. Okay? So the same way, right, this is only 5 values, but this curve does not end. Okay? It didn't just start at the origin and stop at 2 pi. It's going to keep going. And this is where I'm going to use that idea of it being a periodic function. It's a repeated function. And help me out, okay? Help me figure out what the next points are. So we started at the origin. We bounced up to the maximum, down to the minimum, and now we're coming back up. So my next point here would need to be up to the maximum and then I'm going to head from the maximum back to the middle. Okay, so I can use this same idea, right? You can kind of follow the curve. Okay, so here's my hit the maximum, but now I'm moving to the left, so I'm going to go down to the middle, down to the minimum. Okay, back to the middle, to the maximum, to the middle, minimum, middle. Okay, and now I'm going to play connect the dots. But again, sine is a smooth, continuous curve. Okay, so as you're playing connect the dots here, make sure that you are curving through the points. There are no sharp points here. This isn't a V shape. It's not a W shape. Please do not draw those for me. All right, I know that your curve won't be great. I mean, I can even look at mine and go, wow, I have some issues here, but try and make it curved. Okay? So once we've got the curve drawn in, we are going to use this pretty little curve to fill in all of our key features. Okay? Domain, we're looking left to right. This is a smooth, continuous curve, no gaps, no breaks. So negative infinity to infinity. Okay? Range, we're going to look at our minimum to our maximum, and this curve bounces back and forth between those two. It does not ever break out of them. So our lowest point's -1, our highest point's +1. Yes, you need to use brackets with those. Okay? Period here, we're going to look at, a few of you do the maximum to maximum. You absolutely can do that. For this one, I'm actually going to go middle to middle here, okay, because the origin actually works pretty nicely for this one. And that's actually going to get me a period of 2 pi. Okay. Maximum, we mentioned it already in the range, is a +1. Minimum was mentioned in the range. It's a -1. The midline is the average of your maximum minimum. So I'm going to take the maximum plus the minimum, and the midline is going to be y equals 0. Okay, amplitude is half the distance between your minimum and maximum. So take the maximum minus the minimum. So that's going to be a half of 2, and your amplitude is going to be 1. Okay, so that's the graph of the basic sine function from the unit circle. Okay, actually, yeah, I'll go ahead and leave it as it is. What I am going to do, though, is there's 2 more quick problems on here just dealing with some key features. I'm going to go ahead and hit those before I cut the video. If you're comfortable with finding key features you were good at from the last mini unit, feel free to stop the video, move on, and do something else. I am going to go into the next set. I'm just going to change color on my pen here. All right, so find the key features listed. Domain for your periodic function is going to be, let me get this a little bit bigger. So domain is going to be from -infinity to infinity. Range, I want to talk about the bottom of this curve. So the bottom of this curve is going to be -3, and I need the top of this curve, which is +7. I don't know why I just put a parenthesis. That should be a bracket. Fix that. Okay. Maximum, I just said it is +7. Minimum, I apparently can't spell the word minimum when I typed. That should be -3. I don't even know what word that says. So I'm going to find the amplitude. Amplitude is 1/2 the distance between our 2 values. So that would be 7 plus 3 is 10. Half of 10 is 5. So amplitude of 5. Midline, I'm going to do the average of the 2. Okay. So 7 plus -3 is 4. Half of 4 is 2. Midline is y equals 2. Now, I do check this to make sure that it looks appropriate. So if I put in a line here at 2, that's supposed to be my midline, And then the way you can check it is to actually count up and down off the midline for your amplitude. So if I count 1, 2, 3, 4, 5 up, okay, so that works. And then 1, 2, 3, 4, 5 down. Absolutely, this has definitely got the right midline and amplitude. And last but not least, I'm looking for the period of this function. And there's a couple ways to do this. I'm actually going to go, I will do minimum to minimum. So minimum here to minimum here. And let's see, this minimum is 3 pi. Let me put this down here. So I'm going to do 3 pi minus this other minimum is negative pi. So I just lost my negative sign there, so let me fix that. So this would be 3 pi plus pi. Add them just like you would any other values. 3 pi plus pi is a period of 4 pi. That is probably really difficult to see the top of the pi symbol there. There we go. Let's move that up. Okay. So that first graph is taken care of. I'm going to go ahead and move on to the second graph. And apparently I still can't spell the word minimum. All right. So domain, negative infinity to infinity. My range is going to be from the bottom of this equation, which in this case is negative 7, to the top of this equation, this graph, which is negative 1. Okay. Maximum, I just set it as negative 1. Minimum, again, just set it as negative 7. Amplitude, I want to do 1/2 the distance between them. So take your maximum minus your minimum. Negative 1 minus negative 7 is negative 1 plus 7, which would be positive 6. 1/2 of 6 is 3. Amplitude always has to be positive. So if you ever run into a negative answer, something's going wrong. Okay, midline, I want to do the average of the two. So I'm going to take my maximum plus my minimum. Negative 1 plus negative 7 is negative 8. 1/2 of negative 8 is negative 4. So my midline should be at y equals negative 4. So I'm going to take just a second here and make sure that that looks right and it makes sense with my amplitude. Okay, so if I count up from my midline this way, 1, 2, 3, absolutely that was my amplitude. If I count down, it has to be the same, 1, 2, 3. All right, I know my amplitude, my midline are correct. And last piece I'm going to fill in here is my period, and I'm going to really get zoomed in here. I'm going to go from minimum to minimum here, mostly because I could start with 0. And that's 0 to pi, which means this graph has a period of pi. Okay, so that's the end of lesson 4. There's some extra practice sheets on the drive, but folks, first and foremost, if you have any questions, get them to me in whatever way you're going to do it. Message me through Canvas, send me an email, Remind 101 still works.